The AdaCoder framework is a novel adaptive prompt compression framework for visual programmatic models, VPMs, that generates executable programs to answer questions through large language models, LLMs. It operates in two phases, compression and inference. In the compression phase, a set of compressed preprompts is generated for specific question types. The inference phase adaptively selects a compressed prompt, classifies the question type, and generates a Python program to answer the input question. AdaCoder addresses the limitation of VPMs by reducing the input token length and computational load, while maintaining or improving question answering performance. The framework employs a single frozen LLM and predefined prompts, negating the necessity of additional training. It outperforms state-of-the-art models like ViperGPT and LLM Lingua in evaluations. The paper also reviews related work in visual question answering and discusses the importance of interpretability and generalizability in VQA models. AdaCoder is a novel prompt compression method for programmatic visual question answering, VQA, that leverages black box language models, LLMs, to improve efficiency and reduce computational costs. The method compresses prompts for VQA models, such as ViperGPT, by adaptively generating code snippets and API definitions based on the input question type. The compression process involves two stages: question type classification using a classification prompt, and generation of corresponding code snippets and API definitions using the LLM. The total token length of the compressed prompt is calculated as the sum of the lengths of the code snippet, API definitions, and classification prompt. AdaCoder is evaluated on 3 VQA datasets, GQA, VQA-v2, and NLVR2, and compared to two baselines, ViperGPT and LLM Lingua. The results show a 71.1% reduction in input token length while improving QA accuracy on all three datasets. The method is also more efficient than previous prompt compression methods, such as LLM Lingua, which cannot maintain the structure of code snippets after compression. An ablation study analyzes the effect of question type classification on QA accuracy, highlighting the importance of the instruction prompt for specializing code snippets to each question type. The compressed prompts are analyzed, showing significant compression of both API definitions and code snippets. This is achieved by omitting unnecessary descriptions and condensing remaining sections into shorter sentences, leveraging the language understanding and summarization capabilities of black box LLMs. The AdaCoder framework is designed for adaptive prompt compression in visual programmatic models, efficiently generating programs for visual question answering by compressing and selecting prompts based on question types. Experiments demonstrate the effectiveness and efficiency of AdaCoder, with consistently high performance across various multimodal tasks. Future work includes defining fine-grained QA types and improving ILM's understanding of API usage. The research paper discusses the limitations and future directions of AdaCoder, a system for adaptive prompt compression in programmatic visual question answering. It acknowledges the reliance on black box large language models, LLMs, and suggests exploring alternative choices, such as open-source white box models. Future research directions include developing methods for interactive code modification, automatic extension of APIs, and adaptively extracting necessary API definitions and coding examples. The paper also provides an extensive list of references covering topics such as attention mechanisms, compositional visual reasoning, and prompt compression. The authors recognize the need for further exploration of white box and black box LLMs and their combinations, highlighting the importance of pushing beyond the traditional scope of visual question answering.